We're going to explore how we can do data preparation just using Unix shell commands. This is generally a good idea because Unix has some very powerful tools that are agile. That is, as you type them, you immediately get a response. And they're fast because they're written in C and they can also be parallelized quite easily. And finally, they're quite popular. They are available in any environment. That includes, for instance, Google Colab, where I can just type exclamation mark and then run any Unix command, like let's say ls. What this does is lists the files, and you can see that there is something called sample data, and it turns out from the file listing that I do actually have a folder called sample data. So let's do this. Let's take a sample data cleaning exercise. What I'll do is download a set of log files. These are the web logs from my site, which is at s-anand.net, and we'll specifically take the log files for the month of April 2024. So that is at this particular URL. I'm going to wrap this in quotes and use the curl command to download this. Now, just so you get an idea of how curl works, let me type bang curl minus minus help. The way curl works is you can type curl, put in a bunch of options, and then specify a URL, and it will fetch that URL. This is a partial list of options. I can say minus minus help all to get a full list of options, and as you can see, it's a pretty long list. Some of the options that we are going to use now, one of them is continue at. In case the download gets cut off or if the file already exists, then it will continue from that point. A second option that we will be using is the follow links or location, which is out here. What that does is, in case the redirect points me to some other place, it will take me to that particular URL instead of just stopping at that particular point. The third and I guess more important one is the output file. We'll say minus minus output file name, which is where we want to save this particular output. So let's do that. The first option I'm going to provide is minus minus location, which will follow redirects. Not that this is very important. Continue at hyphen, which will restart the download, but again, not very important. Minus minus output, and this is important. sanand.net dot let's call this hyphen April 2024.gz and the URL. Now let me press Shift Enter and run this. It's fetching the file and it's completed it. Now, to verify that this exists, I will use the ls command, and ls will list the files, and I can see that the file exists. Now, ls itself has a fair number of options. If I said ls minus minus help, you can see that well, there's all of these. One of them is a minus l, which uses a long listing format, and the advantage of a long listing format is that it will show the size of the file as well. So I can say ls minus l to see that eventually, yeah, here. This particular file, this log file is 5.8 megabytes in size. We're going to be using a command called gzip to uncompress this. That's because the file is in a gzip format. And how do I know that it's in a gzip format to save it as a gzip file? Because I created this file, so I know that it's gzipped. There are other formats as well. xz is another format that is slower but much better in compression, but we are just going to be using the gzip command. To use gzip, we have to type gzip and then specify the file name with a decompress option. Let's actually do a gzip minus minus help. Yeah, it says I can do a minus minus decompress and the file name. So decompress s hyphen it should do autocomplete. Yeah, here we are, and press enter. That has, it says decompress the file. Let's see whether it's actually working. You can see that this file size is now roughly 9 or yeah, about 9 times larger than the original file size. It's about 52 MB compared to the 5.8 MB that there was. Let's take a look at these log files. one of the commands I can use to see the first few lines, let's say the first 5 lines, is head. Head minus n5 will show me the first 5 lines of s-anand.net April 2024, and this is what the file looks like. We have the IP address that's sending the information, we have the date and time of the request, we have the actual request that was being sent, and a bunch of other data. Let's look at the last 5 lines of this same file. I can type exclamation tail minus n5 sanand.net April 2024. I'm going to copy this file name so that I can just paste it regularly. And you can see that this goes on up to 30th April, but starts on 31st March, somewhere around 7 a.m. Eastern time, I guess. Now, uh, there are a number of things that I'm curious about with this data set. For example, I want to know how many requests were made to my website in this time period. Let's roughly call this April. To do this, I can use the word count command. WC, any file name, will tell me the total number of lines, that's the first response, words, and characters in the file. Lines is what is of interest to me, so I could just do minus L to get only the number of lines in that file, and that's 208539. So roughly 200,000 requests were made in April 2024. So that's useful to know. Now I'm curious, who has been sending most of these requests? So let's basically get the IP address that sent these requests and count them. To do this, we have to get the first column, and for that we are going to use the cut command. Now the way cut works is you can specify a delimiter, and in this case the delimiter is space because between the first field, the second field, and the third field, and the fourth field, and so on, there are spaces. By the way, the second field is something called ident d. I have no idea what that is. The third field is the username, which in this case doesn't exist because nobody is logging into my website. The fourth field actually is not uh, I mean, it's a composite field. It has two things: the date time as well as the time zone. The fifth field is enclosed in quotes and contains the actual request made. Then the sixth field is the size. The sixth field is the HTTP response that the site sent. The seventh field is 686, which is the number of bytes that was sent as response. The eighth field is the referrer, the page that sent a link to my site. The ninth is the user agent, that is the browser they were using. And there are a couple of other fields which we can ignore. So these are separated by spaces. At least the first field is separated from the second by a space. And I want to get only the first field. So minus minus fields 1 from the file sr.net, whatever. This will get me the first column. This will print a long list if I just press enter. So I'm going to get the head of this. Now you'll notice that I'm typing pipe head. What that does is takes the output of the first command and passes it through the second. Head, as you remember, will give me the first however many lines of the file. If I said minus n5, it would give me the first 5 lines. If I don't specify a file, it will take the file from the input, which has been piped into it. So clearly, I am now able to cut the first column and get the results. What we'll do next is sort this and then find out how many unique values there are. So let's say we sort, and there's a command called sort that does exactly that. And let's say we look at the first 25 lines of this sorted. So there are a few duplicates like these. So this particular IP address has sent 7 requests. So I'm curious, what is the count of requests from each IP address? To do that, I can use the command. Uh, let's copy the previous one. Take the sorted values. I can use a command called unique, UNIQ, and UNIQ has an option called minus minus count that will count the number of unique values. Actually, this will work only on sorted files, so you can't use unique by itself. But once you sort it, you will be able to use that. So let's look at this list. And yeah, it's saying that there was only one request from here, one request from here, and so on. But were there any duplicate requests? Let's say we want to see the first 30 and see there are any duplicates. Yeah, so that dot 83 had 7 requests, and we can see that. Now I'd like to sort this list further, so I'll say sort, but instead of just sorting alphabetically, I actually want to sort by a key. In this particular case, the key is the first key, that is the count 1 or 7 or 2 or whatever. And once sorted, I want to see the last few lines, the last maybe 10 lines, to see which are the biggest. Okay, that oh, okay. It's clearly sorting, not alphabetically. I'm sorry, sorting alphabetically. I need it sorted numerically. And to do that, I have to add an N to this. Sort has its own little language where I can specify the field and whether it's alphabetical or numerical. Having done that, now I get this sorted, and what I find is something strange. So there is this particular IP address which is sending 101,000 requests to my site, and my site only got 200,000 requests. So practically half the traffic is from this website. So who is this website? So there is a site called whois.com where I can just put in an IP address and it will tell me who owns this IP address. It looks like there is a hetzner.com, but it's coming from Data for SEO. Who is Data for SEO? Data for SEO is an API stack for data driven SEO tools. Okay, so they aggregate from search engines, and this therefore is probably a search engine that's crawling my site. Fair enough. The second largest is some other IP address that's sending 7,800. Now, this is interesting. But let me get back to the first one. It's obviously a bot of some kind that is scanning my site. Does it identify itself as a bot in the user agent? Let me check by searching for all the requests that it's sending. To do that, I can use the command grep. Grep does a search for, in this case, I'll use this particular IP address. Now, what it does is searches for regular expressions. Now, what regular expressions are, okay, that's a field in itself. I very strongly urge you to learn regular expressions, but they are a mechanism of wildcards that you can use to search for content. One of the things that I can do with regular expressions, for example, is specify a caret at the beginning. That means that the string should start, the line should start with this particular piece of text. So it's not match this text anywhere in the line. It's match the text specifically at the beginning of the line on the file asan.net, whatever. And this will give me 100,000 rows, practically half the file. Let me just look at the first few lines. I'm just curious to see what the user agent is. Okay, so the user agent is Mozilla 5.0 compatible data for SEO bot. So they have identified themselves, and not just that, they're also passing the URL so that I know what exactly is being sent. Let's look for the second one and see who's sending this traffic. Okay, this seems to be coming 7,000 requests coming from Apple WebKit, HTML. Okay, this is helpful. Chrome version 30. Now, Chrome version 30 as of June 2024 isn't, or even April 2024, is an ancient version. I don't really believe any human, firstly, would be able to send 7,800 requests to my site uh, in 1 month. I mean, nobody's that interested in my site. Secondly, no human is likely to be using Chrome version 30. So this again must be a bot, but this is a bot that is not identifying itself. Well, let's get back to just the bots that are identifying themselves. Can I find all the bots or all the user agents that have the word bot in them? So it turns out that I can, well, I could just say bot, but that may not be such a great idea because I mean, if my site had the word bot somewhere, then it'll probably hit that as well. If it had a song that had the word bot, I don't know if I can find an example just here, but I'm sure there would be one. Maybe I should look for, um, uh, okay, Not sure how exactly I should search for it, but let's even start with this. Also, I want to see what are all the unique bots. Now, in each of these cases, when there is the word uh, bot, okay, it's identifying itself as Apple bot. So as long as there is a word that contains bot in it, I'm still good to just see what that is. How do I do that? So it turns out that I can use regular expressions for this. There are some special characters. In this case, I'll use backslash s. Backslash s matches any non-space character. So I'll say backslash s star. So zero or more non-space characters and a backslash s star at the end. So this is basically saying anything that has bot inside it and is surrounded by spaces. Take that portion and print only the matching parts. This will give me a result where it just gets that chunk. So it's picked up applebot 0.1 and then apple.com/go/applebot. This is another chunk. All of these chunks are surrounded by spaces. And as long as they are surrounded by spaces, it treats it as one unit and prints it. So let's do the same thing. What we'll do is sort these and get the count of these. Sort by the first key numerically and get me the last few rows so that I see which are the biggest entries or which are the bots that are crawling my site the most. Okay, data for SEO clearly Apple bot in two strings of Apple bot. Then there's Google bot. Interesting that Anthropic for Claude is crawling my site a fair bit. Bing, understandably, is crawling. Robots.txt is actually a request made to my site. And there's a site Petalbot, whatever that is. Let's look at what this Petalbot is. Okay, so it's part of the Petal search engine. Good. Learned something new about search engines today. Now, what I can use this for is any kind of analysis, which I could do maybe even in a spreadsheet. Now, as you can see, this file is almost a CSV file separated by spaces. In the sense that there are fields, the fields are separated by spaces, but it's almost because this whole thing is one field, but instead of being in quotes, it's in square brackets. Let's see if we can replace this particular square brackets thing with quotes. Now, here's something that you should know in general these days. There's no point remembering all of this stuff. The stuff that I typed so far, I remember because I've been doing it for many years. But the stuff that I'm about to do, I don't know how to do. And I'm not going to try and figure out how to learn it. Instead, I'm going to go to ChatGPT. And on chatgpt.com, once it loads, I'm going to ask the question. I have a file that, let's make it bigger, has dates. Okay, I have a log file that has dates in the format this particular thing. I write a one line shell script that replaces this with, and instead of these, I'll put uh, in quotes, and let's see what it does. Okay, it's saying you said to replace the brackets with double quotes, and here's the one liner. Okay, this will replace the thing. Okay, explain how this works. Okay, and it's saying this is the search pattern. The backslash quote, sorry, the backslash square brackets, the beginning and the end, they escape the square brackets. So that's saying that we are going to search for stuff that is inside square brackets. And the stuff inside that is capturing everything inside the square brackets. Uh, Specifically, it's saying that uh, anything except a square bracket repeated inside square brackets. So basically, start with the square bracket and capture the open bracket indicates it should create a capture group that is basically remember the stuff inside. And the capture group should contain anything other than a square bracket and then ends with a square bracket. I kind of understand this because of the use of regular expressions in the past, but otherwise I just trust it or verify it better yet. And then it's saying replace it with double quotes. The backslash one is the text that was captured within brackets earlier. All right, fine. So let's do that. We'll copy this and replace log file with whatever our file name is, and make a few more changes. So that's sanand.net slash whatever. And I can save this output by pressing typing greater than. If I type greater than at the end of any command, it will save it to whatever file name I specify. So I'm going to call this log.csv and press shift enter. It's going to run this. And now let's see if it's created another file log.csv. Yes, it has. Let's do a head of log.csv to see if it's actually gotten the quotes in. Yeah, it's gotten the quotes and it seems to be doing a good job of it. So I can download this CSV file and open it in Excel as a text delimited file. Let's just verify that. Um, say head log.csv. Let's take the first 1,000 lines into small.csv and run this. The reason I'm doing this is because I don't want to download an entire 5 MB file and open it in Excel. I could, but I'm just saving myself time. And click on download. It's downloaded it. Now let me open this file. Hopefully it'll open it in Excel. Yeah, it's opening Excel. And at this point it will complain saying that this is not a CSV file or it's going to get it in the wrong format. That's okay. Yeah, maybe what I'll do is rename this to a text file because it's actually not a CSV file, and then try opening it. Let's click on this. Okay, I offline renamed that CSV to small.txt. Now let's open this, and it's saying delimited. Yeah, delimited by a space in this case, and just continue and finish. Yeah, this seems to have a reasonable structure. I have the IP address, the two fields that I don't care about, the date, which includes the time zone, and so on. And any extra fields? Looks like we do have, at least in a few cases. Well, in exactly one case, the first 1,000 rows, some an extra field. That is specifically happening for something that has byte spider. Let's take a look at what was in the original data here. So I'm going to do a grep byte spider in small.csv to see what that line contained that causes this problem. Okay, looks like there's a whole bunch of byte spider requests in this file, but the request that we are interested in is from the IP address out here. So I'm going to say starting with this and then having byte spider somewhere in the middle. The way this regular expression was crafted, let's go back here. Yeah, is I put in the IP address. Dot star means any character repeated any number of times and then byte spider. So let's see. This request has anything unusual. There doesn't seem to be anything unusual here. So, oh, I see. Okay. Uh, the URL itself seems to contain quotes. Yeah. The URL itself contains the word devotional songs, but devotional is in quotes. And because of that, there is a misalignment. So we'll have to factor this in. In case the request itself contains quotes, then how do we make sure that Excel doesn't deal with that? We're not going to go into the details of how to do that in this particular case. I checked offline. There are only about 40 such instances, which we can, if required, handle manually. Now, we've looked at a bunch of commands like grep. We've seen sed, which is a stream editor that does search and replace. We've looked at cut. We've looked at ls. We've looked at wc for word count and so on. This does not cover the bulk of the shell commands. In fact, it's a minority, but these are the most frequently used shell commands. And there is a book published by O'Reilly called Data Science at the Command Line, which teaches you more about how you can use Unix tools to process the data. But hope you got a sense of how you can use some of these command lines in an agile, interactive way to get a feel for the data as well as transform it into the kind of format that you need.